Hey, good morning, or at least it's morning here for me. Welcome to another vlogging with log or whatever I'm going with at this point. Um, Today we are going to talk about mixtures, and we call mixtures our fancier term for anything kind of mixed in water, um, a solution. So water itself is not a mixture; it's a pure substance. But tap water is a mixture. My coffee this morning is a mixture because there's stuff mixed in with water. Just a little bit of review here on some terminology as we kind of go through the next couple of days. The solute is the substance that's being dissolved. So in my coffee, when we make coffee in the morning, water kind of percolates through the actual coffee grounds. The solute in my coffee is the actual coffee. And the solvent is what's doing the dissolving. That's usually water. However, it doesn't always have to be. So one of my favo things to drink, usually it'll happen in the afternoon, is Kool-Aid. The actual Kool-Aid powder and the sugar, that's the solute. The solvent is the water. Whenever I decide to go shower and I put perfume on, perfume, when you spray it in the air, perfume would be the solute, and then in that case, the solvent would be the air. So it's kind of usually the thing that you have more of would be the solvent. Whenever anything mixes in together, we say that it's soluble. So like sugar is soluble in water, salt is soluble in water, oil in water. Oil does not dissolve in water. That is insoluble. So I thought it would be fun to start with a little bit of review. Here's remember how ionic compounds, when they dissolve, they dissociate. I'm going to just write one out for you. Sodium chloride, it's ionic, it's a solid. When that dissolves, we end up with sodium ions and chlorine ions. We're going to pull these back next unit, actually, so we'll do a lot more kind of writing dissolving stuff. Whereas table sugar, C12H22, let me scroll up a little bit, is not ionic. It's a covalent compound, but it is solid. That just stays together and becomes aqueous into the solution phase. So a little bit of review if you forgot about that. Usually, if you go to make Kool-Aid and you want it to dissolve really, really fast, the quickest way to do that is to start with hot water. We learned last unit that if you increase temperature, the molecules move faster, and since the water molecules are moving faster because they're warmer, you're going to be able to dissolve a lot more sugar faster. So just FYI. Oh, my neighbor, this past winter, we did like a sledding party between our houses, and then we went over to her house to make hot chocolate. And she sat there, she took cold milk and then poured the hot cocoa powder in and stood there stirring it forever before heating it up. And she kept complaining that the chocolate wasn't dissolving. I mean, it was just doing it really slowly, but that's why if you ever go to make hot chocolate, start with hot, like either water or hot milk or whatever you drink it with. Anyway, I just mentioned this though. Our fancy word for stirring is agitation. All that does is that adds more kind of energy to the mixture, making stuff move more fastly so things can dissolve. And then surface area. If you go and you buy Kool-Aid, they don't sell Kool-Aid in big bricks of Kool-Aid. They have it broken up for you into little crystals. That's because the water is able to come into more contact, or more water is able to come into contact with more of the actual Kool-Aid particles. So the larger the surface area is, the more the water can come into contact with it, making things dissolve faster. So these three things affect the rate. But let's talk about what affects how much is dissolved, and we call that solubility. So because we're online, it depends on what things you're trying to dissolve in what. I'm not going to focus too much on that at this point. We would have spent more time in class kind of talking about it. But this is specific for solids. If you increase the temperature, you can get more solid to dissolve. And this for me usually plays out when we go, or when I go to like Starbucks. So if you order an iced coffee, so something that's really cold, and then you go over to the side counter and add sugar to it, the sugar won't dissolve because sugar dissolves endothermically. You have to add heat to get sugar to dissolve. So most solids dissolve that way. So if I want to make really salty water, I have to add heat to it to get it to make the aqueous side of the reaction here. Hot tea versus cold tea, you can get hot tea sweeter because the molecules are moving faster. They're able to hold more solute. Versus like iced tea, if you go to put sugar in it after the fact, it's really hard. Kool-Aid, it's kind of funky, but if you started with hot water, you can actually get more sugar to dissolve. So as the temperature increases, the amount of solid that can be dissolved goes up. So this is like a piece you'll see. The gases, it's the opposite. As you add heat to it, the gas molecules move faster, so it gets harder for the water to keep the gas dissolved. So that's why if you've ever like left a pop out and it's warm and then you open it up and you go to drink it, it's going to taste flatter because there's less gas dissolved. As the temperature increases, again, it's the opposite. There's actually less gas dissolved. Which is kind of how my husband and I got into one of our first fights. I bought a brand new car. This was before we like had moved in together. He's got an addiction to drinking pop. So we went to meet some friends out on the lake for the summer. It was like an August day, and he had bought a 12-pack of Coca-Cola but forgot it on the front seat of my car. So we were gone all day. Car was sitting in the sun all day, and we get off the lake, go to my car, and it looks like somebody had broken all the windows in my car. And as we get closer, the windows weren't broken. All 12 cans of Coca-Cola, because they had gotten so warm and the gas undissolved, it needed somewhere to go, blew up in my car and coated every window in dried, baked on Coca-Cola. It was a really good fight. We fought about gas solubility that day. So this is also why, in case you're at home, fun activity to do, we did this last night, was have a burping contest. If you are going to have a burping contest, you need to start with cold pop. The colder the pop is, the more gas is dissolved. And so as you drink that, you're taking in more dissolved gas, and as it warms up, the gas undissolves and needs to bubble out somewhere. So if you're going to have a burping contest at home, start with cold pop. You'll get more gas into your system. So that's my brief little intro to solubility. And now the next video, I'll talk about how we kind of quantify how much is dissolved.